So market clearing prices are great in resolving conflict. Each person gets their favorite item, and we even have seen that the total value, the combined value of all buyers and sellers, is as high as possible. However, we haven't thought about, do these things exist? So we want to prove that they exist, and to do that, we're going to just show you a method of how to construct market clearing prices. The basic idea is that we maybe start with all zero prices, set up a preferred seller buyer graph, and if there's a matching, we're happy. If there isn't one, then we try to improve it by raising prices on the over-demanded set. So let's try to see this in an example, and we're going to assume that all numbers are integers. So as I said, we're going to start with all zero prices and set up the preferred seller graph. So maybe these people, their usual set of Shin, Yoram, Zach, and Will, have preferred prices for 4 different items. If the preferred seller graph happens to have a perfect matching, then we're all set. Indeed, these prices we currently have are market clearing prices, and we're done. So our trouble is if the preferred seller graph doesn't have a perfect matching. But we have seen that if a graph doesn't have a perfect matching, it has a constricted set. So what we should think about, where is this constricted set? In this particular graph, I circled with S, the constricted set. And what makes special a constricted set is that it doesn't have enough neighbors. So if I look at the neighbors, it has fewer neighbors than the size of S. What this means that this neighbor set, which is C and D in our case, are over-demanded. There are only 2 items in it, and there's 3 people who would prefer to get one of those. So what market clearing prices will have to do is somehow resolve or help with this conflict, and what might help is raising prices. So we take the neighborhood of the constricted set and raise prices. So this is our basic algorithm. We find the constricted set and raise prices. So why exactly is raising prices helpful? Once we raise prices, the increased price on the items that Yoram, Zach, and Will wanted will make them want it less, and in particular, they might start preferring something else. So in our example here, they started to prefer A and B respectively. And if they have other preferences or add additional preferences, then maybe we've now find a perfect matching. So again, we're done. We found a perfect matching with any set of prices. That set of prices is market clearing, and we found our market clearing prices and its perfect matching. If there isn't a perfect matching, then we just repeat the whole process. We find a new constricted set with the new set of prices, raise prices again, and keep repeating till hopefully something good happens. So, okay, this is our basic algorithm. We start with 0 prices, set up preferred seller graphs. If we find a matching, we're set. If not, there's a constricted set. If there's a constricted set, we find one, we look at its neighbors, raise prices in the neighbors, and try again. Keep repeating. So what can go wrong with this process? Basically, it's trying to aim at market clearing prices by constantly raising prices. So one issue we should be worried about, that maybe the prices go too high. And after all, if the prices get above people's values, then they simply won't be interested in buying things. And that's certainly not going to work. If we want market clearing prices, and we had in this setup the same number of people and items, if we drive the buyers out of business by raising prices too high, that's not going to result in selling the items. So we're going to need to go back and add one more step to our algorithm. If it looks like prices are dangerously high, we can just lower them. So let's go back to what our algorithm was so far. So our algorithm so far looked like looking at finding perfect matching if possible, if not, raising prices and repeating this process. So I want to add one more step. If all prices are positive, we could just take and subtract 1 from each of the prices. So now our algorithm will be, as we had it before, setting up preferred seller graphs, looking for perfect matchings or alternative to constricted sets, raising prices on the neighbors of the constricted sets whenever we find them. But if we ever find ourselves in a situation where all prices are positive, then we can subtract 1 from each of the prices. So why is this last step good? Subtracting 1 from each of the prices is good because it doesn't change the preferences. If every price went down by 1, I want everything, or every buyer wants everything a little bit more. They got one additional value for it, but the preference of which one they want more doesn't change. And what's nice that this way the lowest price will always stay 0. Whenever all the prices are positive, we just took one off from everything. So the lowest price being 0 guarantees that people will want to buy, and we didn't drive them out of the market by raising prices too high. So where we are now, we have an algorithm. It consists of raising prices when they're constricted sets and occasionally lowering prices if every price went positive and we're worried that they're rising too high. The only way this algorithm can end is if we ever find a perfect matching. Otherwise, either we raise prices because of a constricted set or lower prices because everything goes positive. There's one more issue you need to worry about, however. Maybe this process will never end. We're sometimes raising prices and sometimes lowering prices, so one should wonder whether are we making progress here, or are we just, cycling between one price and another set of prices. So this is what we're going to come back to next time and wonder about next section, and show that the process in fact ends and finds market clearing prices.